Good afternoon. Thank you for joining us for our news conference with members of the Expedition 29 and 30 crews. To my left is NASA astronaut Dan Burbank. Dan was born in Manchester, Connecticut 50 years ago today. Happy birthday, Dan. He considers Yarmouthport, Massachusetts to be his home. He joined NASA in 1996 and has flown on 2 prior missions. He flew on STS-106 in 2000 and STS-115 in 2006. He and his crewmates will launch on a Soyuz spacecraft on September 22nd from Kazakhstan for a 6-month mission to the International Space Station. We'll let Dan introduce his crew. Thank you.
Thanks very much, Nicole. Thanks very much, and it's great to be here with you today. Myself, my crewmates, we've just kind of come to the end of a pretty long and event-filled 2 years of training to get ready to fly this mission. Having been to the space station twice on board shuttle missions, for me anyways, it was enough just to whet my appetite for space flight. So the opportunity to spend 6 months on board station is something I've really looked forward to. And I'm also very much looking forward to flying with 2 very good friends of mine here to the left, and 2 exceptionally talented cosmonaut pilot engineers. And to my left immediately is Anton Nikolaevich Gaplarov. He's a colonel in the Russian Air Force. He and his wife, Tatiana, are both from Sevastopol in Crimea in Ukraine, and they have 2 daughters, Christina and Kira. Anton was a licensed pilot before he finished high school, which is more than I can say for myself. He graduated from Kachinsk Air Force Flight School in 1994 as a pilot engineer with a degree in aeronautical engineering. He was a senior instructor pilot. He flew the Yak-52, the L-29, and MiG-29. And he was also an instructor in general parachute training with hundreds of jumps to his credit. He was selected as a cosmonaut in May of 2003 and worked for a period of about 6 or 8 months here at the Johnson Space Center as the representative for Roscosmos, the Russian space agency, as the director of their operations here in Houston. And he is the commander of our Soyuz, and he'll be a flight engineer on board the ISS with me. He's already trained twice to be a backup crew member for previous crews, and this is his 3rd training flow, and very much looking forward to flying with Anton. To Anton's left is Anatoly Alexeyevich Ivanishin. Anatoly is a lieutenant colonel in the Russian Air Force. He and his wife Svetlana are from Irkutsk, which is about 2,500 miles east of Moscow, on the shores of Lake Baikal, the world's oldest and deepest lake, and in a real beautiful region of wilderness there. They have 1 son, Vladislav, who's in college studying computer engineering. Tolya attended Irkutsk Polytechnic Institute and Chernigov Higher Military Aviation School, graduating with honors in '91. And in 2003, he graduated from the Moscow State University with degrees in economics, statistics, and information theory. In the Air Force, he flew the MiG-29 and the Su-27. He, like Anton, has hundreds of parachute jumps. I have 0. But he was selected, as was Anton, in 2003 as a cosmonaut, and he'll be a flight engineer on board the Soyuz that we're launching on, and also on board Space Station. And again, two great friends, and very much looking forward to flying with them. I could give you a summary, maybe, if that would be useful, just of the major events we have planned for the expedition, and we can maybe use that as a branching point if folks have some questions. I guess if I were to summarize one thing about how our expedition perhaps differs a little bit from the previous ones, is the emphasis is squarely shifting towards utilization of research on board the space station as being the primary goal. Up until now, assembly has really been the major focus, and with the recently completed last launch of the shuttle, all of the major heavy lifting's been done, and space station is essentially at an assembly complete phase. We do have some operational and assembly type activities that we plan on board space station, but again, research is the focus. For the big picture operational events, like Nicole had mentioned, we're launching on September 22nd, docking on September 24th, and when we get there, we'll be joining Mike Fossum, Sergei Volkov, and Satoshi Furukawa, and we'll spend about 2 months with them, and then they will leave, and shortly thereafter, at the very beginning of December, those 3 will be replaced with 3 other friends, Oleg Kononenko, and Don Pettit and Andre Kuipers from ESA, and we'll spend another almost 4 months with them, and our expedition is scheduled to last until about the middle of March when we return, and we've got some visiting vehicles that we're very much hoping and looking forward to seeing while we're on board Space Station, one of which at least, and hopefully more, will be the first of the commercial resupply ships that'll come to Space Station. And that'll be a busy time leading up to that, but something I think we're all looking forward to. We have one spacewalk planned, and Anton can talk to the details on that. And another thing that we have planned that sort of falls in line with some of the assembly or at least upgrade kinds of events is we've got a pretty major planned upgrade of the space station avionics, including the computers on board and the communication systems, such that we can increase the bandwidth, the amount of data that we're able to exchange with the Earth. And kind of in a nutshell, if I were to encapsulate at least the things that we can plan, that's pretty much our expedition for the 6 months we'll be there.
All right. Did Anton want to? Any remarks? Okay. With that, we'll open it up for questions here from the Johnson Space Center. Go ahead, Robert.
Hi, Robert Perlman with CollectSpace.com. You mentioned this transition over to utilization. How has your training differed, if at all, to prepare for being more of a research crew than an assembly crew?
Right. I guess in the big picture, not a lot, Robert. We always, and all the crews leading up till now, have trained on the payload, so the science end of it's always been an emphasis. There's a lot of the training that we do that prepares us for certain kinds of contingencies that probably aren't necessarily in the science research end of it. I think the reality of the way space station research is conducted is a lot of it is conducted remotely by scientists and researchers on the ground. We get a chance to participate with that, sometimes almost to the level of being a co-investigator, but sometimes just being a lab assistant and maybe just being a source of the data as a lab rat, if you will. But a lot of that kind of work, because the primary responsible entities are the folks on the ground, the details of that, we will get chunks of training throughout the 2 years plus that we train together, and a lot of the things we can actually do real time and learn about those on orbit. So we had previously had about a 4-year training flow. It's down to 2.5 or less right now, which means it's pretty aggressively targeted at all the contingency kinds of things, the emergency things, the EVA training, robotics training, some things of which, if everything goes well, you may not ever do. So I don't know if that answers it, but.
Yes, thanks. And as you're going to be the first full expedition without the space shuttle, so without really a guaranteed down mass capability, has there been more constraints put on either your personal items being taken up or how you do science results in terms of delivering that data or objects back down to the ground?
Well, down mass is a critical capability that the shuttle has given us for a long, long time. And so far, it's been the only vehicle that can return the science results, if those are in the form of samples, for example. The only vehicle that could return hardware back to Earth. So if we want to, for example, with the pump module issue we had on board Space Station, if we want to be able to diagnose it, to look at it and see what had happened so we can learn from it, the shuttle gave us a great opportunity to do that. As far as the upmass goes, with STS-135 and the couple of missions leading up to it, Space Station's actually in a really good posture right now for logistics, and we have more than enough to allow us to basically do all the things we need to do on station for at least a year. So we're in a good situation with regard to that. The only planned vehicle in the near term that would give us the capability of returning a significant amount of down mass would be the SpaceX Dragon vehicle. We can bring some materials back with us on the Soyuz, and we've done that for quite a while too. What we have done with STS-135 returning is we basically took the huge stockpile of things that needed to come back from station, a lot of those biological samples, and basically emptied all of our reserves for that and returned them all to the laboratories on the ground to work on. We hope to see SpaceX in early December, and if we do, we hope to get some down mass capability with that vehicle. And again, that's a really important capability we'd like to have long term. The things that you can do via telescience, that is, if you can do analysis on the science you're doing and send data down to the ground for them to remotely analyze it, that's something that the upgrades to the avionics will help. But there's still a lot of things we want to be able to return directly to Earth.
Bill Horowitz, CBS, with a couple of questions, and I'll start with you, Dan.
Okay.
Just kind of following on that, this is the first flight in the absence of the space shuttle, and it kind of sets the tone for the next era in the station's evolution. What's your confidence level going into this? You mentioned a minute ago those are the things you could plan and tell us about, but things that are unplanned happen, and you've lost the ability to carry heavy components up. Maybe just your confidence in continuing station operations in the absence of shuttle and the spares that are available on board, just all that kind of stuff.
As far as my confidence on space station being able to continue, given the logistics situation we have on board, I am really confident about that. We have the outside of space station, we have put in every location we could all kinds of external stores for all the big equipment that we potentially could foresee having an issue with. Inside space station, we have tons and tons of logistics ranging from food and water right up to the various experiments and science equipment, and lots of spares for the things that are inside station as well. In general, I would say this. The time I think is right. I think, and I hate to see the shuttle be retired, frankly, as someone who's had the privilege to fly twice on it. It's a sad thing when we retire any space vehicle, you know, at least from an operator's perspective. And the space shuttle was exquisitely well designed to do the kinds of things it has done now for decades. And again, it was the capability to return large pieces from space. I think low Earth orbit, it's probably the right time now to come up with a different kind of capability. I think getting from planet Earth, the surface of planet Earth, to low Earth orbit now is within the reasonable reach of commercial companies, and I really do applaud that. This is a very exciting time in that respect. I think NASA's job, it always should be, and probably always has been, you know, at least certainly in the very, very early days, and I think it always should be doing the very hardest things you can do. I think it's right for us to leave low Earth orbit and get into deep space. And those destinations range, as you know, from asteroids to the moon to Mars. There's lots of great places to go, but all of those things require require us to redirect the resources that we've got. And so I think it's an appropriate thing for the government to absorb and shoulder the high risk, you know, potentially higher costs of developing heavy launch capability and crew vehicles that are designed to do deep space type missions. That's a good thing. And for us to contract the services to get to and from low Earth orbit, I think it's a good thing. Now, with all that said, spaceflight is still really hard. It just is. I mean, it's right at the ragged edge of what we humans can do with what we know about material science and propulsion technology and everything else. It's just a very tough business, and we've seen some very impressive innovations and designs on the part of the commercial resupply contractors, and we've also seen some good indications that there'll be the capability before, you know, hopefully too much longer down the road, of having of human, you know, launching capability on commercial vehicles. That's a good thing, I think. Space station, I don't worry about it. We're covered for the immediate near term, and I would love to see things accelerate apace. The more vehicles we can have that can get us to space, the better it is, and the healthier it'll make our space program as an international effort.
Thank you. And one question, the same question for Anatoly and Anton. What are you looking forward to the most for your first space flight? I mean, what is it that you want to do when you get there, and what are you looking forward to the most? If I'm okay.
I have never been to space before, so I'm looking forward to feel something which I have never experienced before. It would be extremely interesting for me to see a blue planet with my own eyes. Of course, I have seen it a lot of times as pictures made by cosmonauts, astronauts, satellites, but I really believe that when you see it by your own, it's something really amazing. I'm looking forward to meet the current International Space Station crew. It happened that I spent certain amount of time preparing to the space flight together with Satoshi and Mike. He used to be a backup for Dima, Kedi, and Paula, so I know these guys very well. And I'm really looking forward to see them in the new conditions for me of course, they have already acquainted to the space environment, but it will be new for me. And I'm looking forward for my job on board the station. I do believe that experiments cosmonauts and astronauts conducting space helps human beings to reveal mysteries of nature. And we are going to do experiments in many areas, from medicine, biological, geophysics, remote Earth sensing technologies, space material science. And I really believe that this work will help to improve life on our planet.
Я могу только добавить, что сказал Анатолий, что
I would like to add a few
уникальность
words.
нашей космической станции и проводимые эксперименты в
The
ней
fact
заключается в том,
that
что
our ISS is
те
really
условия,
unique,
которые
based to the
есть на станции, то есть это такие как микрогравитация, перегрузки, которые мы можем испытывать, а также влияние в какой-то степени радиации, это те условия, которые мы не можем возвести на Земле. И только работая и проводя эксперименты в космосе, мы можем добиться тех или иных результатов, которые от нас ждут ученые.
I would like to say that the ISS is a really unique environment, and it presents us unique opportunities to experience zero-G loads, overloads, and unique conditions in which to test and to conduct experiments. I believe this is really important, and I look forward to doing this in space.
All right, thank you. Jill?
Jill Tolk, representing Bay Area Houston Magazine, with a couple questions. First of all, for Dan, I had interviewed Steve Bowen recently where he had that unscheduled STS-133 flight plus the spacewalks, and he described that event as a good model moving forward for the International Space Station, where, of course, astronauts are trained for skills rather than just tasks for the ISS. So could you expand on his comments a bit?
Yeah, no, that's a great point, Jill, and Steve said it well. The way we approach training on the shuttle is very different than the way we can reasonably approach training on the space station. The shuttle, partly because of the way that it flies in such a dynamic environment, and also because the crew is at a much greater, at least percentage of the time, involved directly in controlling the vehicle, we're able, and the missions are shorter, probably is another huge thing. We're able to train to what we call in our communities here a task-based level. And what that means is you, as a crew member, are basically trained to know that if this light comes on, this tone is in your ear, and this little indication on a panel goes to this configuration, that it means such and such has happened, and you know almost without even thinking that I need to do these 1, 2, 3, 4, 5 steps or whatever. And we can do that by training literally hundreds or thousands sometimes, over the years, ascent runs and entry runs in the simulator. And if you're going to train for a 2-week mission, you can do that. On space station, you got 1 million pounds almost of hardware, and it's unbelievably expansive. And like I alluded to a little bit earlier, the ground to a much greater degree is actually directly controlling the systems, and more so than they do on the shuttle or have. So maybe 80% of the vehicle is being directly controlled by people here in Houston, people in Moscow, people in Europe, Japan, and we are there to facilitate and help where there are things that only crews can do. The space station, now that it's up in space, is going to basically continue to fall, if you will, around the Earth. So there's not a lot of things that can happen that, no kidding, the crew has to be able to respond to very, very quickly. So what we try to do is we try to give the crew a toolbox of skills, basically. Teach them, basic kinds of things, generally how such and such a system works. What are the particular things to watch out for when you're doing this activity? And then the idea is that with that skill set, they can apply it and basically quickly learn through what we call on-orbit training, where we can uplink files, we actually have simulators for certain activities we can actually practice in orbit, and then learn how to do it, and then go out perhaps next week or the week after and be able to do maybe a very complicated series of EVAs, or we could repair a piece of hardware that we maybe never saw in pieces on a bench in front of us. But the thing that's hard about that, at least on the maintenance end of it, I think, is that with the shuttle, any time that something might have happened where the crew had to fix it, you always knew that all you had to do was stabilize the system, and then you were going to return it to these brilliant professionals at KSC who had taken care of it all their lives. And so the crew's job there, from a maintenance perspective, was jury rig something, patch it together like the ground tells you, and it's going to go to somebody who's going to make it basically, pristine in a very, very short period of time. At Space Station, we can't do that. Space Station, suddenly crews potentially have to do the kinds of repairs that are commensurate with what people that have done it all their lives have done on the ground. So it's a challenge that we're facing. But again, generally you have the time to do things. You can do it methodically. We can teach ourselves with the ground's help how to do things, and skills-based is really the practical way to do it. And I think we're seeing that a lot of times now.
Thanks for the good words.
Yeah.
A related question for Anton or Anatoly, whoever would like to take it. We've heard the American side of spacewalking, but I wanted to get a Russian perspective too, because Russians didn't necessarily rely on the space shuttle, but what is the Russian contribution for spacewalking, let's say for the next year or two, skills-wise?
We are going to perform one EVA from Russian side. It's interesting to point out that the number of EVA coincides with the number for increment when it's going to be conducted. And Anton and Oleg are going to be the operators who will go outside. And the tasks for this mission is to install a protective shield to the SM external surface, and to conduct a couple of experiments. And one of them is выносливость. The name of the experiment can be translated into English as endurance. It's a brand new one. And this is research how space environment impacts mechanical properties of materials intended for space. And during this experiment, Anton and Oleg are going to transfer a unit which consists of 2 trays to MRM2. And at the external surface of MRM2, they will install 2 trays. Each of them consists of metal samples, and these samples will be exposed to the space environment for a year and for 3 years. Then they will be returned to Earth. And the novelty of this experiment, the materials will be exposed under the condition of real space flight, subject to loads and not subject to loads. And they will be at the same conditions and the modules itself. And this experiment becomes especially important today when we see growth in development of space machines, which has set a series of tasks regarding designing and creating new space systems, as well space systems of new generation, as well as space material science. And I hope Anton can add what I have missed about his space work.
В добавлении сказано Анатолием, хочу сказать, что одной из больших задач на этом выходе, которым будем, как говорил Анатолий, делать вместе с Олегом Кононенко, это сбор образцов различных отложений на самых различных компонентов Международной космической станции. То есть будет специальная укладка, в которой будут находиться такие палочки с ватными головками. Мы аккуратно будем собирать в тех местах, которые будут указаны с земли, образцы отложений. Эти дальше образцы будут отправлены на Землю, где ученые будут определять, что именно оседает на нашей станции, как оно влияет на поверхность станции, и тем самым будут прогнозировать, как долго сможет летать станция. Мы знаем, что возраст станции уже, если считать ее с момента начала постройки, более 11 лет. Сможет ли она долетать до 20 лет, до 2020 года, как сейчас по программе есть, и как дальше она может летать еще вперед. И это будет большой вклад для того, чтобы наши космические агентства, главы космических агентств могли определить, как долго сможет летать станция, и мы можем на ней работать.
Yes, I'd like to add to what Anatoly said about the EVA I'm going to perform with Oleg. We're going to sample the resident substances that are left on the station on the outside. For that, we have a special kit. We have cotton swabs, and we'll try and sample those substances, and then we'll send the results to the ground. And that's how we'll know what settles on the construction of the station outside, and that will help us determine for how long the station can be in operation. They know that the age of the ISS is already 11 years plus, and we'll find out whether the station can survive and be safe till 2020 and maybe beyond. This will be a contribution for the heads of the agencies to decide what to do the station next and for how long it can be in operation furthermore.
All right, next question.
Swain reporting for the Bay Area Observer. This question is directed to Dan Burbank. As the first mission after the space shuttle's programs end, what historical significance do you think this expedition has?
Well, apart from the fact that it'll be the first mission that'll be continuously run without the capability of the shuttle to be there, I think what it really represents is this transition from space station being in an assembly mode, basically being, if you can imagine an airplane being built as it's flying through the air. Space station has been very much that. It's got pieces and parts assembled all over the world, most of which never actually came into contact with each other before they did in space. It was a very complicated thing, just incredible and very impressive and very uplifting that it went as well as it did. And the things that we learned as we assembled it are going to be invaluable down the road. The shuttle played a major part in that. Space Station is now a very capable, world-class research facility in orbit, a very unique place. And it's something that I think is going to enjoy a long legacy. As Anton mentioned, we have already all agreed, international partners that are members of this team, that the space station will be operated out till 2020, and I hope and I expect it'll be operated quite a bit longer than that. But now that assembly is complete, it's time to actually get our return on the investment and start to concentrate on the science and research that space station was built and intended for. So we'll have basically 6 people for the foreseeable future living, and perhaps more down the road, but for the foreseeable future living and working on space station, with hundreds of people all over the world that are also tending experiments and operating those 24/7, 365. And I think we're already seeing some of the benefits of that, and we're going to continue to see more. For us, all 3 of us coming from pilot and engineering backgrounds, to get an opportunity to do the science, just as Tulya had mentioned and Anton had mentioned, to get an opportunity to be a part of that and to participate in the science and research aspect is really neat. And I think it's a credit to our organizations that we have taken operator-trained people and engineers like ourselves and given us a broad base of skills that'll hopefully allow us to contribute in a good way on it. So I guess the history is that this is the beginning of a new era without the capability of the shuttle, but we've also got a number of vehicles right around the corner that are going to help to fill that gap.
All right, any follow-ups? Okay, we're going to switch over to the Kennedy Space Center where we have 2 additional journalists.
Thanks, Nicole. It's Irene Klotz with Reuters. I have a couple questions for Dan, I think. Could you describe in detail the training that you've had for Dragon operations, and if you've had any for Cygnus as well, and also who's prime and who's backup for those spacecraft operations?
I guess I would say just in general that we already have some experience with visiting vehicles that have come the way that Dragon and Cygnus, the orbital sciences vehicle, will come to station. We've had 2 Hope transfer vehicles, HTV-1 and HTV-2, that already came to station. And the way those vehicles work, at least from the perspective of the operations that we conduct leading up to that, it'll be essentially transparent to the crew. Our operations as far as monitoring the rendezvous, monitoring the vehicles as they come up what we call the R-bar towards the space station forward, nadir or Earth-facing side, and then how we track and capture them ultimately with the space station robotic arm and then mate them to Node 2. Those are essentially the same. The arm geometry may be a little bit different, but the generic skills that we train in the robotics and in the visiting vehicle flows are all the same. I've been out to the SpaceX facility in Hawthorne, California, and I've gotten to see the vehicle and talk to the people out there, and have seen how the logistics, for example, and how we will interact with the vehicle as it's coming up. How there's what we call a CCP or command control panel that we use to actually issue commands to the vehicle as it flies up the R-bar. There's a point where we'll basically command the vehicle into free drift. So it'll be, after it's station keeping in a stable fashion beneath space station, we'll basically tell its motion control system to stop firing the jets, and then it allows us then at that point to bring the space station robotic arm up and then very gently and carefully capture it, and then we'll maneuver it to mate it to the Node 2. Identical the way we've done it with HTV as well. That piece is probably the most critical piece of the operation. Getting a chance to see the vehicle as we did in Hawthorne, getting a chance to see how the logistics will be stowed on board, that's really not so critical, but I did get a chance to do that. It's the kind of thing that I guess, as Jill had asked earlier, it really kind of falls in the category of skills-based sorts of things. It's not time critical. We can work and coordinate that with the ground. But I think it'll be very similar to what we've had with the HTV vehicles before, and the MPLMs and other modules that have come up to the space station. At least the docked or mated phase will be the same. Orbital, I've learned about the Cygnus vehicle and trained here at JSC and basically about to the same level as far as the operations in the mated phase. And the robotics we've done, and I've flown many in the simulator tracking captures with Orbital, as I have Dragon and the other vehicles. So don't know if that's the answer you're looking for, but feel pretty well that feel pretty good that the training we have so far is adequate, and that we've got a good set of skills to be able to do those activities safely.
Thanks. That's a very thorough answer. Who's your backup for those operations?
Oh, my backup, excuse me. It wasn't thorough enough. But yeah, so depending on the timing of the vehicles, I think right now we're looking at the Dragon vehicle, the Dragon demo vehicle, to come up in early December. That would potentially, if the dates stay as planned, mean that vehicle would arrive at space station about 1 week after Don Pettit and Andre Kuipers arrived at station. So that's a very busy time. It's a time for them to begin their adaptation to space station, and we also do want to do a little bit of on-orbit training together for that. I think if those were the dates that hold, then I would be prime for the track and capture. Don would be assisting me with that, and Andre would be as well. And Andre's primary job would probably be operating all the berthing mechanism, though that part of the operation. But in truth, really all of us on station to a certain degree are going to be involved in those activities.
Thanks. And I had one other question. There's an awful lot of empty parking spaces around here at Kennedy, and just was wondering what the mood and what it's been like in the astronaut office. I know you're busy training with your mission, but just what it's been like there with this transition after shuttle now underway. Thank you.
Yeah, and again, you know, if I think about this from a personal standpoint. Haven't had the privilege and honor to fly on Atlantis, actually, my 2 flights before this, and to watch Atlantis return home and to see wheel stop and to watch the pride on all the folks' faces as they watched, celebrated the closing out of this wonderful program. There's a part of me that felt a lot of sadness at that. But it's a very bittersweet moment because I really do think that we are setting the stage right now to be able to do even grander things. The thing that I worry about the most is that the people that are leaving the space business in the immediate near term have some crucial kinds of skills, things that are very, very hard to come by. And if we don't get them back into the fold and get them working on the new vehicles and helping us with the next step, then it would be very, very difficult for us to recreate that talent on the fly. And I just hope and pray that we will be aggressive and in our next activities, and that we can return as many of those folks back to this business as possible. And it's important also beyond just the people that have had the opportunity to work on these spectacular vehicles. It's also really important for us, I think, as Americans to have space vehicles, to be doing this business. We do not spend a lot of money on the space program. When it comes to, dollar per dollar, it is a very, very small amount when you look at the U.S. federal budget, about 0.5%. And what that means is, for that very little bit of an investment, we get an awful lot of return. We get to have a space station that's manned 24/7, 365, and it is not just a space station. It is an unbelievably impressive place to see. We have all the deep space probes that have been doing all the research for NASA for years and years. We have the aeronautics research that NASA does and all the other things. The 0.5% encompasses an awful lot of things. One smaller piece of that of which is the human spaceflight part. But what we get out of that is we inspire the next generation, people all over the world and people in our schools here in the United States see these kinds of things, and it gets them excited about doing this in their future. And I think that's a really important legacy, and maybe it's one of the biggest paybacks that NASA gets. So on the one hand, again, it's a little bit sad. On the other, there's an awful lot of opportunity right now, and I am very hopeful.
Todd Halverson of Florida Today for one or both of the cosmonauts. I'm wondering what your thoughts are on the retirement of the space shuttle fleet at this time in the life of the International Space Station, and your thoughts on the fact that the partnership will be relying on a single vehicle to get up and down the station for the next several years. Thanks.
Я могу сказать, что, во-первых, сама программа шаттла — это была большая, великая программа, которая оставила очень большой, значимый след в истории освоения космоса. Конечно, мы жалеем о том, что шаттлы прекратили летать. Мы, как профессионалы, понимаем, что это была вынужденная мера. Лично я сожалеть буду о том, что не увижу полет шаттла, не увижу, как он пристыкуется к станции и дальнейшее возвращение его на Землю во время нашего полета в космос. Но на этом программа не закончилась. Программа космическая продолжает идти своим чередом, все по плану. На место, скажем так, устаревших кораблей будет приходить новый, то, о чем рассказывал Дэн. И хочу напомнить, что, как я считаю, именно с программы «Шаттл», именно со стыковки шаттла с космической станцией «Мир» началась эта большая, грандиозная совместная программа России и НАСА, то есть российской стороны и партнеров. И после этих совместных полетов «Мир-шаттла» было понятно, что необходимо строить совместно станцию, новую станцию, Международную космическую станцию, на которой мы сейчас работаем.
I'd like to say that the Space Shuttle program was a huge and a tremendous program that made a great impact onto the process of discovering space. And as a professionals, we understand that the retirement of the Space Shuttle was a measure which was necessary to be taken. And from my own perspective, I'm really disappointed that I would not be able to see the shuttle dock to the station. But the program is going on however, and new spaceships will replace the old ones. And I'd like to remind everybody that from the point of docking of the Mir space station and the shuttle, the program of cooperation between Russia and NASA began, and then it was carried on by Russia, NASA, and all the other international partners. So the shuttle and the Mir station became the grounding stone in the future discovery of space and in the future startup of the new, our present ISS, International Space Station.
I knew that STS-135 launch was planned before our arrival to the station, but I hoped that because we have a practice that shuttle launches are quite often shifted to the right, I hope that it will happen. Unfortunately, it never happened, and we will not have such an opportunity to go inside shuttle on orbit, and I'm really sad about it. But looking forward, I think that new commercial vehicles from orbital and Cygnus will be able to provide station with all the necessary stuff, and I'm looking forward to see them.
All right, thank you. And now we'll be switching over to a couple of questions via our phone bridge. First, we have Denise Chow with Space.com.
Hi, thanks. A question for Dan Burbank. As has been mentioned before, if the timelines stay the same, your crewmates and you will be present on the space station for the test flights of both SpaceX and Orbital. Could you characterize the significance of those milestones and also how important they are for the future operations of the space station?
I missed the very end of that. Characterize the significance of, and I missed that one word.
For the future operations of the space station.
Okay, yes. Getting logistics to space station is crucial. I mean, and let me just, at the risk of oversimplifying things, leaving low Earth orbit and getting to 17,500 miles at 400 kilometers, getting to that speed at those altitudes is really hard. It takes us about 20 to even 25 pounds of propellant, high explosive propellant, engines, and tanks to hold the propellant for every useful pound that goes to space station. So what that means is your clothes, your food, your equipment, the air and every breath that you take, the water you drink, all of that, if we weren't able to reuse as much as possible, all that would have to be resupplied at great expense. There's a lot of work being done on space station right now to close the life support loop, to basically, we have a urine processor and a water processor, though the job of those two pieces of equipment is to basically take urine from the, we drink, we metabolize products and we generate urine, but to take that and convert it into ultra pure water. And then the water we can drink, the water we can also split that molecule into oxygen to breathe, and we can, and then the hydrogen we typically would pour overboard. We inhale and metabolize the oxygen and we generate carbon dioxide, and we historically have taken the carbon dioxide and scrubbed it out of the atmosphere and thrown it overboard. So all of those two, the hydrogen, the oxygen, the CO2 that we lose overboard, we're now able to replenish. So with the regenerative environmental control system, we have a way to basically take the CO2 that we breathe now, the excess, and take some of that hydrogen that otherwise we're getting rid of, combine the two, and make some more water to feed back into the loop and reclaim a whole bunch of mass that otherwise would be lost. And it also makes methane, and the methane you could also use, that actually goes overboard, but that's fuel. If you were doing this technology on the moon, or more likely on Mars, for example, you would basically recycle all of those things and you would make a little bit of methane that would power your rovers or basically fuel your ascent stage, for example. We're not perfect at all that. We're just learning how to do that. There's a lot of good technology that's in that particular suite of equipment, one of which is the water purification beds. We're actually using that same technology in third world countries and disaster areas and so forth. It has a lot of applicability on planet Earth, but it solves our problem on space station also. But it's not complete. We're not completely successful. We do lose some. So no matter what, we need to have a logistic stream to basically return things that we lose, to basically resupply space station. And in that capability, which is crucial, is being supplied in the future. Well, it's always been for a long time now with the Russian Progress cargo vehicles, with the HTV, the Hope Transfer Vehicle that the Japanese produce, with the Automated Transfer Vehicle, which the Europeans produce, and now we're replacing essentially the shuttles piece with these commercial vehicles from the U.S. We're going to get better. We're going to get better at recycling the materials we have on station, but we're not going to ever close it completely, and we're always going to need to get spare parts up, and that capability is crucial. And its capability, it's not just crucial for space station. I think it's crucial for America to support a space-based economy, or a piece of our economy that's space-based in the future. That includes a space station, but other places as well.
Our next question is from Anita King with the Harvard Journalism Department.
Yes, a question for Dan. With the end of the space station, the space shuttle program, do you think the American community is thinking that international cooperation is now much more of an important feature for international space exploration? And how can you encourage that understanding, especially among young people here in this country? And a quick question for Anton or Anatoly. What is it about space exploration that seems to be desirable among young people and transcends cultures and nationalities? If you could speak to that. Thank you.
Okay, Anita, I guess the first part there, I think in general, one of the difficult things about this is the people that, a significant portion of the people that fly in space right now are not necessarily the people that are especially good at talking about it. We're operators, we're engineers, we're scientists, but I think it's a very, very important thing that we dedicate enough time while we're up there to basically tell the story of space exploration. I mean, it's exciting. There's plenty of people all around the world that are lifelong converts, and you don't have to sell the story to them. But for other folks, it's important to understand that the things you do on space station help life on Earth. For kids, it's important to convince them that science, technology, engineering, and math are good things to do. They're fun, they're interesting, but they are investments in our future. So whereas we'll be very busy and there'll be a lot of work to do on station, I think we'll also have plenty of time to do educational kinds of events and try to come up with compelling ways to get that story out. I think, to me, as one of the believers, lifelong believers in this business, sometimes it's a little hard to understand why people wouldn't get all fired up about it, because it's fun, it is interesting, it's our future. I believe passionately that humans are going to not just live on planet Earth for the indefinite future. It's our destiny to do these kinds of things. It makes us better, it lifts us up. We need the kinds of frontiers that space uniquely now provide us.
Мы знаем, что этот год объявлен Международным годом космонавтики. 50 лет, как впервые человек поднялся в космос, Юрий Алексеевич Гагарин. И мы видим, что сейчас очень сильно поднимается интерес как детей, так и молодежи к космосу. Мы много ездим, много выступаем перед молодежью, перед детьми. Могу сказать, что видно, что вопросы, которые они задают, они уже не детские, не такие, как, например, что вы кушаете, как вы спите. Вопросы намного интереснее, которые интересны с технической стороны. Возможно, многие эти вопросы они подчеркивают из фантастических книг или фантастических фильмов, но видно, что интерес молодежи очень сильно растет. Нам приятно выступать, рассказывать им. Много задают вопросы, а как же стать космонавтом? Мы рассказываем на примере себя, как мы пришли в отряд космонавтов. Говорим другие пути, что не обязательно быть военным летчиком. Каждый человек, который стремится, который поставит перед собой цель стать космонавтом, может достичь ее.
Well, we all know that this present year has been called the International Year of Space Exploration. It all started 50 years ago with the first flight of a human being, of Yuri Gagarin. And we can all see that the interest for space science, for space exploration is growing. as cosmonauts, we make presentations also to children, to youth, and we can hear that their questions that they ask us are not those of children or of ignorant people. They do not ask us how we sleep in space or how we eat. Their questions are more of a technical side, and probably the reasons for that are maybe science fiction books or science fiction movies or stuff like that. And it's always a pleasure to talk to them. We also tell them about how we became cosmonauts, how we became part of the cosmonaut corps, and we say that it's not only that it's not really necessary to be a military pilot to become a cosmonaut. You can come to the cosmonaut corps from many other fields and many other professions.
On orbit, we'll take part in conversation with students of school students using ham radio, and we're going to answer the questions. There is also ability for us to send them pictures which they can receive using ham radio technologies. And it's of course it's important to help to understand young people that they should work hard, because their success in studies is their ticket to the future. As well, we are going to conduct a series of experiments which, like microsatellites, which has been done by college students. And our mission is just to throw them into the space.
All right. With that, we will wrap up our briefing. Thank you, Dan, Anton, and Anatoly, and thank you all for joining us. A reminder, we will be having live television interviews with Dan Burbank airing here on NASA TV at 3:10 p.m. Central Time. Thank you for joining us.